In this short video, I want to remind you of how the equation for a straight line can be manipulated in order to make predictions about the data. So the equation for a straight line is y equals mx plus b, where y is the quantity that's plotted on the vertical axis, x is the quantity that's plotted on the horizontal axis, m is the slope, and b is the y-intercept. The slope is how steep the line is, and the y-intercept is the value of the y-axis quantity when x is 0, or the place where the line crosses the y-axis. So in the cases that we're discussing in the context of this lab, we have on one hand the COVID-19 data, where the y-axis quantity is like a number of people infected with the virus, and the x-axis quantity is time. Or in the case of the Amazon.com share price, y is like the price of the stock and x is like time. They're very similar. So I'll use a p to represent the y-axis quantity, and so for the Amazon.com example, that would be the share price, and for the COVID-19 data, that's the number of people. Well, thousands of numbers of people in the case of that data set. And then the x-axis quantity is time. So I'll use a t for that. Now from the fits to the data, you have values for the slope and for the y-intercept b. And the equation of the line is set up to predict values of the y-axis quantity if you plug in values of the x-axis quantity. It's all solved and ready to go. So if you want to predict the price of an Amazon.com share, you know the slope, the y-intercept, you plug in the value of t, which is when you want to know the price, multiply, add, you get the price. But what if you want to predict a time when the price is a certain value? Or in the case of the virus data, what if you want to predict the time when the number of infections is a certain number? So how do you solve this equation to predict times if you know the y-axis quantity? So there's a few basic algebra steps I'm probably sure that you remember. You want to get time all by itself on one side of the equal sign. So the first step in all of this is going to be to undo any additions or subtractions. So in this particular case, we're going to want to subtract b from both sides of the equation in order to remove it from this side and end up on this side. So that would result in a formula that has p minus b over here, because you subtracted it off, and you're left with m times t over here because you subtracted off the b parameter. And then the last step is going to be to divide both sides by the slope, because you would like to get time all by itself. So the only thing you have to be careful of is to divide everything on the other side of the equal side by the slope, not just one of these quantities or the other. In any case, you end up with a formula that will predict the things that you need. That the time when the y-axis has a certain value is calculated using this formula. Sorry my writing is so scribbly, but I'm having a hard time writing on this pad. In any case, you can use this formula to predict the time when the y-axis quantity has a certain value. And about the only thing that'll trip you up is this minus sign here. You have to subtract even if the y-axis, the y-intercept itself is negative. So if you end up subtracting a negative number, you actually end up adding. So you just have to be careful of the signs.